This is Free Stuff Finder, and we are going to Heartland.
We're coming to Heartland on November 17 with stories about the biggest collisions in the universe ever. Planets ramming into other planets, stars smashing into...
I think it just wanted me to absorb stuff right now. So let me do that real quick. Let's go. Okay. But on mount. Oh, I needed to go there. I bought the computer full sale. So we are gonna make games. Okay. Gotta go. Dang it. Okay, that one was just too close to the other.
Hey, we made it to Heartland! On our podcast, Daniel and Jorge Explain the Universe, we like to talk about planets and galaxies, but we never thought we'd get to do it from another world. And here we are in Heartland. How cool is that?
So cool. Now, on our podcast, Jorge and I typically talk about some of the biggest, most amazing unanswered questions in the universe. And today, we have some really fun stories about the biggest collisions in the universe. Planets colliding with other planets, stars colliding with other stars, even galaxies hitting other galaxies.
But before we get into it, we just want to give a quick thanks to our partner, State Farm and Intel, and of course, Roblox for having us here. Hi, I'm Jorge. I'm a cartoonist and the creator of PhD Comics.
Hi, I'm Daniel. I'm a particle physicist and a professor at UC Irvine, and I love to smash things together to figure out what they're made out of.
Welcome to our podcast, Daniel and Jorge Explain the Universe, a production of iHeartRadio.
in which we try to smash your brain together with the whole universe. We think that there are so many interesting things to understand out there, and we want to bring your brain together with all of those questions and give you some understanding of how things work.
So today we'll be breaking down some of the biggest collisions in the universe. Now that's kind of a tricky word to use, biggest, because especially in physics, that can mean a lot of things. Like it can mean biggest in size, it can mean biggest in speed, or biggest just in terms of the impact that they have on our planet.
Or biggest in drama, right?
Oh, I see. We're going for drama. So, what would you say are some of the biggest collisions in the universe?
Well, we do some pretty fast collisions here on Earth. We accelerate protons to almost the speed of light and smash them together underground in Switzerland. So you got a proton going at the speed of light this way, proton going at the speed of light this way. That's a pretty dramatic collision. That's pretty big stuff.
That's really one of the biggest experiments humans have ever done.
Yeah, absolutely. It's one of the most expensive and one of the biggest experiments. So I'm basically a shill for big collision because it's my day job.
And you said you smash protons together, which are tiny little particles that are part of the atom. So we're all made out of atoms, of course, and the atoms are made out of stuff inside of them, including electrons and protons.
Yeah, so we take hydrogen, which is a proton and electron, we pull away the electron because we're not interested, and then we just smash the protons, the hydrogen nuclei together. And sometimes just like proton debris comes out, and sometimes weird new stuff comes out.
What even weird new stuff?
Well, one of the amazing things about collisions with particles is that what comes out doesn't just have to be a rearrangement of what went in. You can actually annihilate it and turn it into something new, like a Higgs boson or a photon or a Z boson, or something you didn't even know existed.
Now, how do you smash these protons together? Do you have like slingshots? Do you pull back and like two scientists stand in front of each other and then pull back and smash the protons together? How does that work?
So we take the protons and we push them really hard with electric fields, and then we bend them with magnets so they go around in a circle. And we do that over and over and over again until they're going really, really fast. And we have another beam going the other direction, and then we cross them.
So that's one of the fastest collisions
Whoa,
we know
whoa.
about as scientists.
Dude, that's faster.
It's weird because
Okay,
we
let's
actually
try.
are making that collision.
But it actually doesn't even compete with what the universe is already doing all the time.
Wait, what? I mean, there are things in the universe smashing close to each other faster than twice the speed of light.
Absolutely. The universe is filled with huge particle accelerators that are throwing particles at us that are colliding with the Earth much faster than the particles are moving in the Hadron Collider.
Okay, so that's maybe another type of collision of things smashing together that we can talk about is cosmic rays coming from space.
Exactly. Cosmic rays are a fancy word, but they just mean particles in space zipping towards the Earth and then smashing into the atmosphere like tiny little meteors.
Now, these things normally would be kind of dangerous, right? Like if you're hit by one of even though they're tiny particles, if it's going fast enough and it hits you, it can actually kind of not be good for you.
The atmosphere is like a blanket that protects us. They hit the atmosphere and they bounce against particles in the atmosphere and they lose a little bit of energy. By the time they get down to the surface, instead of having one particle with a lot of energy, you have like trillions with a little bit of energy. So you see these big showers of particles hit the surface of the Earth.
So then it's a good thing to have our atmosphere to protect us from these cosmic rays.
Yeah, it's like a
pretty
shield.
dangerous universe.
Exactly. If you're in an atmosphere, you go out into space, you really need to think about shielding. Because there's a lot of crazy stuff out there in space. Maybe you think about space as being empty, but really it's filled with high-energy particles whizzing all around. It's quite dangerous.
Asteroids, rocks from space that come flying towards the Earth, they kind of get burned up in our atmosphere because they hit that air, and then they create all that friction, and then they burn up before they hit the Earth.
Yeah, the atmosphere is like a big bucket, and if the rock isn't too big or going too fast, then it melts in the atmosphere. Sort of the way like spaceships, when they re-enter the atmosphere, they get heated up. The same thing happens to asteroids and meteors.
Awesome.
Hey Daniel, what's the most powerful force causing some of the biggest collisions in the universe?
Well, there's this thing deep in space called the Great Attractor that's pulling everything towards it, and we don't know what it is. And now it's your chance to be the Great Attractor. Climb up onto the platforms to collect all 9 planets for your chance to win rewards.
Got 3 so far.
But I said speed and energy are really important, right? And sometimes we want to create these collisions. Like the ones we talked about, I know you were doing to study things and also what we observe up there in the sky. But sometimes we want to create these collisions, maybe even to save the planet Earth. Yeah, this is pretty cool. I don't know how many of you know this out there, but NASA, the space agency of the U.S., has a program called the Planetary Defense System, right? Like that's somebody's job, is to literally like stand there and be ready to save the Earth.
I'm glad somebody's doing it because it's not my job.
You know, they're trying to save the Earth on a daily basis. And so this happened recently. They sent, what did they send? Like a spaceship, like a little spacecraft, and then they just accelerated it and aimed it towards this asteroid.
Yeah, the spacecraft, it's like the size and weight of a refrigerator. They basically slammed a fridge against a big rock in space.
Not like an actual fridge. That would have been pretty cool.
I mean, they stocked it first. You know, it's filled with good drinks and all sorts of stuff like a normal fridge. No, it's like a huge cube of metal, and they just slammed it right into the asteroid to see if they could change its course.
And it did, right? Like they
totally
measured
did.
where it was going before, and they hit it with the fridge spaceship, and then they noticed that the asteroid kind of changed course, right?
Yeah, it really did.
So we're talking about the biggest collisions in the universe, and we're talking about the fastest ones that we know about. But you could also maybe think about biggest in terms of like impact, right? Like how it can affect us here on Earth.
Well, the Earth is getting hit by this stuff all the time. We can't deflect all of it. A lot of it gets melted by the atmosphere. But in our history, we have been smacked by some pretty big asteroids. Like the dinosaurs were not as on point as NASA is in terms of planetary defense. So they got smacked by a pretty big rock about 65 million years ago. It killed off like 50% of all the species on Earth, actually, in about an afternoon.
And it changed life on Earth forever, right? Like we're here because dinosaurs are not.
That's right, it made room for us mammals. So thank you, alien asteroid tossers, or whoever is responsible for that.
Is that also a theory? That asteroid was thrown by enemies of the dinosaur species?
No, but one of my favorite theories is that they reconstructed the path of this asteroid before it hit the Earth, and they think it made 2 passes around. It came near the Earth before it actually hit, which means that dinosaurs could have looked up into the sky and seen it like 10 years before it hit the Earth. So they had their chance, right? They were warned. If they had their science together, they'd still be here. They'd be doing this podcast instead of us.
If that happened again, do you think we'd be able to survive it, do you think? I mean, if it gets past the NASA defense system.
It would be pretty challenging. What actually happens depends a lot on where it hits. If it hits in the water, you're getting a lot of vapor in the atmosphere. If it hits on land, then you're getting smoke, you're getting volcanoes. None of that is going to be very easy to survive. In order to remedy that, you need planet-wide geoengineering projects that I just don't think we're capable of today.
So start building those bunkers. Start investing in that. And big beans. I hear those last also a long time. But that's also not the first time an asteroid hit Earth.
Yeah, we think there's a whole history of these collisions, dating back millions and millions of years. But we also think that very early in the Earth's formation, there was an enormous collision. A whole planet hit the early Earth.
What?
Yeah. Actually, we do think that there were other planets in the solar system which got ejected by Jupiter's gravity early on.
Wow, kicked out.
Yeah.
Kicked out of the island.
Voted off.
Voted off by Jupiter.
We're the survivors.
So far.
But we think that a Mars-sized planet probably hit the early Earth and created an enormous collision, basically vaporized the whole surface, and what came out of it turned into the Earth and our moon.
So weird, like our Earth right now is actually Earth 2.0. Like it wasn't Earth before, and that got obliterated, and then it reformed again, and that's the Earth we have now, which,
Wait
feels
a
like an
second.
upgrade.
They keep doing
I mean,
this.
I think it's pretty good. I
Whoa,
got no notes.
it is faster.
So then a comet can hit a planet. We saw it in the 90s. It hit Jupiter, and it could hit us. And those are actually kind of more dangerous, right?
Those are more dangerous because comets go really, really fast because they come from much further away. So they have more time to gather speed as they come towards the sun. And because they have long orbits, you might not see them until they're basically headed right towards you. Like there could be comets out there right now that take 500 years to go around the sun, and they just haven't seen them yet.
Now, I was around in the 90s when that collision happened. That's when the comet smashed into Jupiter. I don't think I was kind of paying attention, but you were. You were like...
What? What else were you doing,
You
man?
were watching the live broadcast of it, right?
I actually had a telescope focused on Jupiter. I was taking video myself because I wanted to see the explosion. Yes, at home.
Could you see it through the telescope? Like it actually hit it? Like did it happen fast or in slow motion?
It happened pretty fast, and you can see these fireballs be created. Each fireball is like the size of the Earth. We're talking about incredible collisions here.
Fireball,
Too fast.
like it hit Jupiter. Jupiter is gas. So let's get into that. But when it hit Jupiter, it created a fireball. Like that impact was that crazy.
Yeah, there's so much energy. Jupiter is basically a huge ball of cotton candy, like you're saying. But you hit it with enough energy with a big enough rock, and the rock gets vaporized in the atmosphere, and you create a huge ball of fire. As big as the Earth, exactly. So, we're sorry, Jupiter, but we're glad it didn't happen to us.
That is. Alright, so that's maybe the biggest, in the sense of the biggest collisions in the universe. But we said we would talk about the biggest collisions in the universe. Let's go bigger.
Okay.
Like, can you smash stars together? Suns together?
Now you got the trick of it, right? What would happen if you could smash stars together, right? You want to know. Yeah, I'd love to see that. It turns out that's actually quite rare. Our stars in the galaxy are all swirling together around the center of the galaxy, sort of like a big lazy river. So it's not very typical for stars to smash into each other.
I see.
But sometimes things do smash into each other. It does happen.
Now, what would actually happen if two stars collided with each other?
It depends entirely on the velocity. If they're going really fast, then they're going to obliterate each other, just like what happened with Proto-Earth and the other planet. Like a huge spray of stuff.
Weird to think about because you think of the sun as like a ball of fire, right? So like if you take two flames and you smash them together, nothing really explodes. So the sun is actually kind of pretty meaty, right? Like there's a lot of mass in the sun. I mean, there's almost all of the mass in the solar system, and it is stuff. I mean, it's on fire, but it is stuff.
Yeah, it's a huge ball of plasma. It's burning hydrogen. And 99% of the mass in the solar system is in the sun. And so a sun-sun collision could obliterate both of them. It could spray out a lot of this burning stuff. And the temperature would be really incredible, so it would be super bright. Because what's happening inside the sun is fusion to create all that light, and that pressure and temperature would make the fusion happen at a supercharged rate, and it would be like much brighter than the sun has ever been.
Wow. So you basically see a giant spark from the collision, and then it would spray out, and then it would turn off, or would this cloud of stuff, debris, keep burning? It would go out, right?
The cloud of debris would probably reform back into one big star or two smaller stars, but it would take a little while. It would take a few hundred million years probably to coalesce into something else that could burn.
Let's get bigger, Daniel. What can be bigger than two stars colliding?
Instead of just colliding one star, what if you collided like whole groups of stars, right?
Okay. Are you talking about like colliding galaxies?
Yes, exactly. Let's go really big. So like our galaxy, the Milky Way, has hundreds of billions of stars in it, and the neighboring galaxy, Andromeda, is even bigger. It's much more massive than our galaxy, and it's headed right for us.
What?
Yes, exactly.
Somebody throw it at us? Is this another conspiracy? Alien conspiracy theory? The light race didn't work. The asteroids didn't work. Now they're throwing a galaxy at us.
Somebody's just making sure there's a lot of drama in the universe, right? We've got lots of sequels lined up.
That's right.
No
You want
matter what
season
happens.
2, 3, 4.
The good news is that the collision will not actually be that dramatic.
Okay, so the whole galaxy's colliding. That's not that exciting, you're saying, because galaxies are actually kind of empty, right? I mean, they're big,
They're big.
they're bright, but they're like kind of like clouds almost. Like
Yeah.
they're not that meaty.
Yeah, exactly. It's like throwing two handfuls of sand towards each other. Most of the sand doesn't hit other bits of sand. Most of it just miss.
Can we go bigger then? Can you smash things that are bigger than the galaxy?
Of course you can. Man. Of course you can. You can always go
There's no
bigger.
limit to science. And this is where you go, whoa.
But it's part of a big group of galaxies that all orbit each other. So it's like a big object that's gravitationally bound together.
You got
It's a
this.
cluster of galaxies.
Cluster of galaxies. That's
Yeah.
like a lot of galaxies that are kind of moved together.
Exactly. Gravity's holding them together. And then the universe is filled with these clusters of galaxies.
Do we know if our cluster is heading towards a collision with another cluster? Do we know that? Or is it just inevitable?
It's just inevitable. Eventually, you're going to bump into somebody else. Yeah, just like the Milky Way and Andromeda, the universe is trying to push them apart, but gravity is so strong between them that it's pulling them together so that eventually they will collide.
Can we go bigger, Daniel? What's the biggest thing we can, let's just wrap this up. What's the biggest thing we can collide that we can smash together in the universe.
So galaxy clusters organize themselves into something we call superclusters, which are basically like clusters of clusters. And these are huge, enormous things like mind-bogglingly big, like 500 million light years across.
500 million, let's say like a ray of light would take 500 million years just to like go from one side to the other.
This is like a pretty big chunk of the universe. So we call this a supercluster, and we're part of a supercluster, of course. And so superclusters can smash into each other, right? And we actually think that our supercluster is sort of headed towards another supercluster.
Really? You can track it?
You can track it. There's this thing called the Great Attractor, which is a huge source of gravity far out past our galaxy. We don't understand it. We don't really know what's going on, but we notice everything is moving towards it, and other superclusters are moving towards it. So like deep in the future, supercluster collision.
Oh man, and it's all being pulled together by a mysterious force, right? Like we don't know what it is. We can't see anything there that's doing these things.
We think it's probably gravity, but we can't see what's causing that gravity. So yeah, we don't understand what the Great Attractor is.
Wow.
And now's your chance to be the Great Attractor. Jump up on the platforms to collect all 9 planets to win your fabulous reward.
Yeah. I'm just
Right now, the universe is kind of, like you said, organized in galaxies and clusters and superclusters. I mean, these are like kind of like branches out there in the universe. And everything smashes together. Does it all become like a giant ball of stuff, or like a giant black hole, or like a giant star? You know, like what's the eventual, event or consequence of two of these giant things smashing into
Yeah,
each other?
what's the ultimate spoiler of the universe?
Yeah.
Well, you got 2 big forces at play. You have the universe trying to pull itself apart. Dark energy is like accelerating everything further and further apart. And you have gravity pulling itself together. So the question really is like, how much can gravity pull stuff together before dark energy tears everything apart? Because the far future is we have these like islands of stuff separated by space. And so gravity's like trying to gather as much together as possible before the universe tears it apart. So all this stuff is going to end up in a super black hole eventually.
What?
Yes.
So all the stuff that's close to us
Yeah.
will eventually smash together. You're
Yes.
saying that's inevitable in a way. Will form tiny black holes, and then those black holes will crash into each other. That's another interesting collision. Black
Yes.
hole on black hole.
Yes, exactly. We've seen that happen already. Black holes hitting each other, swirling around each other, and creating bigger black holes. They make these amazing ripples in space-time. But that's the future. Everything falls into a black hole, which is then separated from the nearest black hole, and the universe keeps those apart. But everything in our little, like, sort of gravitational well nearby is going to end up inside that black hole.
Well, cool. Well, like you said, I think that watching collisions, thinking about collisions, imagining collisions, sometimes simulating collisions, is a big part of how we understand the universe, right? Because that's kind of how you test things and see what happens. That's how you learn how things actually work.
Yeah, you can see what's inside stuff. You can see how they react with each other.
Piece of
These are
bread,
great
and then
experiments for
finish
understanding the
piece
basic
of-
nature of the universe. So that's why we do them underground on Earth when we can, and we watch them in the sky when they happen for us.
That's how you crack open the secrets of the universe.
Yes,
Right?
exactly.
You gotta smash things together.
Yeah, that's when the spoilers all come out, right? So that's when we're paying attention.
I see, from the drama.
Yes.
The third act drama.
Exactly.
Because I guess you can't just ask the universe how it works. You learn from the drama.
Well, I've been asking, but nobody's answering. So, yeah, it's like a mystery, right? You just gotta pay attention to the clues.
Ignoring you, huh? It is a big mystery, but you.
Customization. Accessories. No. That's rigged. I did the I did. Did I get the badge for it? Then I should have got the item if I did. Where's my badges again? Profile, I could look through profile. Yeah, this. So shouldn't I get the item? Didn't get the item though. It's supposed to be an item you're able to get after collecting all of those. And it's not showing up. This is weird. In the meantime, there's an event thing happening there. Nothing I could do about that though. I guess make sure to like, comment, and subscribe, and I'll see you in the next video. I guess it's a glitch if you try to get the planet head. It won't let you apparently because I got the badge, but I got nothing, which kind of sucks. Hopefully it's fixed. Hopefully they fix it soon. And if they don't, then everyone just has to complain to the creator of this game and Roblox. Oh well. Maybe. I'd say creator of the game first, but I don't think Roblox. Anyway, like I said, make sure to like, comment, and subscribe, and goodbye.